Here's a speed run of Bear Island. You can download the lambdas and VBA in the description. Go. All right, how much revenue will the following sales make? Right, so all these, they're either split with the word with, if they have line or not. So let's have a little room here. So if I want the revenue of the basket, I'm going to use my X-text split, which includes trim. So the revenue here is the hungry basket, which I can look up here and return on here. That's the price we're selling it for. And then the wine, it says, is $40 that we sell the wine for. So if this is nothing, then $0, otherwise $40. So just add those together. Is the revenue for one, it's quantity of 3, and there's level 1. All right, so now I need to have costs, right? So for costs, I'm gonna have food, I'm gonna have wine maybe, and I'll do other also, right? So for food, I'm going to start by getting the ingredients of the basket, right? So I gotta pull that from here, turning on there. So now if I X text split that, again on commas. All right, now I got the name of the ingredients, and then I'm just gonna look up the name of the ingredients on the cost of the ingredients list here. It's the cost of the food. So the wine is $18. So if this is nothing, then $0, otherwise $18. And then the other, it talks about here, right, that you also need this other stuff. So all this stuff we're going to need here. I'm just going to move this over. It's not the basket itself. I don't need a, don't need the period, I don't need the and, but everything else is fine, right? So now by text x equals x, text split all of this by comma. Now I can look these up on the costs. So I look up this on item list, you know, returning the cost is there. So I'm going to put the profit for one here, right? So the profit for one is the revenue minus the cost. That's the profit for one basket. So that times the quantity is the profit. So now the bear is going to steal the basket. So I'm going to add a cost for a bear. So I got to give the bear a treat. So I look up the bear's picture here in order to find out what treat they like, which is here. Now I look up the treat on the cost list. So do that, this again. That is cost of the bear. Here it says the bear is always going to steal it. right? So my profit then is that minus the bear cost, right? So it's that times the quantity is my yes bear. All right, here, maybe bear, maybe not bear. So based on that L5, we got to know if there's a bear or not. So we look here at the bears. I'm going to use a subroutine for this that I have prepared. It is called tallboard. It's just, basically just turns the two calls everything. And the only ones that I care about here are the bears. So there's the bears and there's their addresses. So now I have the bears and their addresses. I need to know the range because different bears have different ranges, right? So I look up the bear's picture on the pictures of the bears and then their range, right? In any direction. So that's the bear's range. Now I'm going to use my distance lambda. There versus there, and this by default is our chessboard distance, which is what we want in this case. So if this is less than or equal to the range, then the bear, otherwise nothing. So now for the profit here, for how much is the cost for the bear, right? I can, put these together to look up the bear. If there is no bear, instead of giving me an error, I'm going to give it some blanks, right? So this will end up blank if there's no bear. So if this is blank, that means no bear, right? So the revenue is the same, right? So the first part of this is the same, but the cost is now, we go back to the actual cost of the basket. If there's no bear, then if there is, we use the bear calculation. All right. So that then is level 4. All right, so for level 5, we have to escape the bears. So back here at the map, I'm going to need some extra maps for this. I am going to do bear range, right? Which is based on my lambda neighbors count. So what neighbors count does is it's going to look at this map here and I'm going to look at the first bear and I'm going to find everything within 2 of that bear. I can see that bear's range is 2. So now I got these 1s everywhere. It's within the bear, within range of that bear. I'm going to do the same thing for the second bear, which also has a range of 2. And then for the third bear, I'm going to do that, but that bear has a range of 1. So now, and those are not, these are supposed to be pluses, right? Because I'm taking these arrays and just adding all the numbers together. That looks like I got all my bear ranges, right? So now what I want to do is make a cost map, right, for the routes. So I'm going to say, how much does it cost in time to go through each one of these cells? And then I can do the route cost from that, right? So actually I'm going to do some find and replace for this, right? So if it's a 1, that means it's in the bear range. So NA cannot travel the gotta paste values these before I find and replace, right? Now I replace the 1s with NA. I'm going to use like a normal font rather than the weird font. The 0s I need to get rid of because that's not true. It's not really the 0 cost. I'm going to leave those blank. Okay, and now I got to fill in the actual cost in time, which is 1 on the sand and 1 on the grass, and you cannot walk on the water. So I have my fill color subroutine, right? So now I've got the cost for the person to walk on everywhere, right? So now I can make a route cost using my route cost lambda. So this, uses a quick little Dijkstra's algorithm to calculate the fastest way to get from some starting location to everywhere, right? So I start with the cost map. I have to start at the airport, which is E27. So I give it E27. So how many steps does it take? So here's the airport. Okay, you can go diagonal 1, 2, 3. Cannot go where the bears are. Looks right. All right, so now the answer is just X indirect of route cost, exclamation mark, and the location. Fill that in and check we're right so far about everything. So we'll do the bonuses. Sharks and bears, I've almost got that here. I got the bears already. Let me add some sharks. And here it tells me 15 rows. So 15 sharks and bears. Game number and 2 that had the smallest answer. So I use my smallest lambda to look up the smallest answer, right? Gross margin is just the answer here. And then look that up on the game number. And that is there. And then the longest time is just the max. The longest time to get anywhere is just the max of this stuff, not including the row label. Stop. All right. And that my time is 11:25. Thanks for watching.